Welcome to an introduction to NX, an integrated solution for product development. My name's Matt Pfeiffer. I work for Siemens, and over the next 30 minutes, I'll be showing you how, by implementing NX into your organization, you can look at more designs more quickly, analyze those designs with our analysis tools, and use CAM to create manufacturing information to generate these components out on the shop floor. All focused on getting your product to market sooner, quicker than your competition. So what is NX? It's a unified and fully integrated solution, as I just stated, that's a complete set of applications from art to part, a consistent interface, and easy to use. I compare this to Microsoft Office products when you consider that each one of those is a unique tool but has a similar interface, so it's easy to understand how to use one to the next. NX is developed in that same fashion, so whether you're doing design, drafting, simulation, CAM, the interface is very consistent so the user can get their job done quickly and easily. So when we look at just the CAD side for a moment, or the design side, it's an advanced solution for conceptual design. So whether you're doing just product design, industrial design, creating the documentation for those designs, it's all inclusive in this product. From the CAE side, or the analysis side, we can do things like structural, thermal, flow analysis, multi-physics applications, and all tied back to the original 3D CAD design. And of course with CAM, or manufacturing information, we have the complete set of tools here for tooling and fixturing design, NC programming and simulation, maybe validation out on the shop floor as well. All in this complete set of tools as we talked about this integrated solution of not only CAD, but then CAE for analysis and CAM for manufacturing. So when we look at CAD, what's it really represent? What are the benefits to you? Well, it allows you to accelerate innovation. And what do we mean by that? What that really means is that you can look at more design alternatives more quickly to come up with the best design, but also being able to manage change efficiently downstream, as that always takes place in the design history. And we do that, through this unified solution. Everything can be knowledge driven, simulation and validation, and of course it's all managed through this interface. So first and foremost, in the modeling side, we talk about synchronous technology. This is unique to Siemens in the industry. It's a patented technology, and this allows us to make changes to designs that maybe weren't even originally intended for an NX design, but we can make these modifications quickly and easily. But even more important than that is that we can use these tools on third-party data. So if we bring in files from another CAD system, we can make design changes to their components many times faster than what the original CAD system could do so. And when we talk about that imported data or multi-CAD use, what can we bring in? Well, of course, IGES and STEP, things that you would expect, but of course then also ideas files, CATIA, SolidWorks, AutoCAD, Pro Engineer, and we can make design changes to all of those files without needing that original data set. So as I start to get into the product here in a moment, you'll be able to look for a few things I'm about to do. I'm going to add components into an assembly at that door that you see there in that image in the top side. And that's just a door that covers up a battery compartment for the recharging unit for a thermal camera, and I'll describe that in a little more detail a little bit later. I'll also see the fit and function as well as how that part might be able to move or open. I'll then model a part in the context of the assembly so I can reference other components in that assembly and use our synchronous technology tools I just discussed to not only create the geometry very quickly. I'll use some things from a feature library, but also making organic changes, highly stylized shape changes to the geometry. So let's go in and take a look at what we're talking about. So as we look at NX, and I've brought this assembly up, this is a thermal camera that fire departments use around the world to look into walls, look at houses like you can see this image here, to look for hot spots, maybe things that aren't visible flames, but there may be fires within walls. And one of our customers uses NX to design, of course, this product. And we're going to use this throughout the demonstration today. Now, one of the nice things that you can do is go out and slice through the assembly. You can actually leave it in this state if you want to. We can even change the orientation plane if we want. So, if we want to change this and rotate it around to another orientation, maybe so we could see internally to these components a little more clearly. Maybe we want to go in and work on some of these computer components inside. We certainly could do that. And you can leave it at that state, or you can just turn that off and leave the model in its original state. So that just gives you an idea of looking at the assembly initially. But the next thing we want to do is add some new components. And what you'll notice is this is a door. This is the door assembly I was talking about with a couple of other components we'll be wanting to use. And we're going to bring all of these in simultaneously into our design. Now as we do so, and they just come in scattered out here in 3D space, now we're ready to start to assemble these. And as we do that, I'm going to go in and look at this pin first and say, well, I'd like to take this and grab its center line, and I'm going to align it with a hole that's out here in that top level assembly you see on the screen. And there's the result that you get. Now, of course, I need to center this up. So I'm just going to grab a couple of faces on the pin and a plane or a midpoint on a part, and that's going to align that accordingly. I also want to take this rubber gasket. Of course, we need to keep this waterproof for the firemen out there. And I'm going to put that rubber gasket inside the door, and then we're going to simply take the door and place it onto the assembly. And we'll have this portion complete then. And we're just going to put this on the pin. You see the result that I get there. And I'll just align this or center up the door on the assembly. And there's the result that we get for placing all those components at once. Now I may also want to see then how this component moves relative to the rest of the assembly. And I can open the door and see, are we going to have enough clearance to get the battery pack out, things of that sort. So you can go in and analyze those types of things as well. But we'll close the door back. And now we'll concentrate on modeling that part that we talked about a few minutes ago. This is going to be a plastic component right here that will rotate on this hole that will then keep this door from opening up inadvertently for the firemen, but will allow them to open it to recharge the battery pack that's inside. So the way that I'm going to accomplish that is just by going out and saying, well, I want to in-place activator. I want to start to work on a new part in my assembly, but I want to see the rest of the assembly in the background for a few minutes. So you see how it dims out, but I can still see that geometry. The next thing I'll do is, I can go up and pick commands off the top of the screen, or I can put commands right on my cursor. And I'm just having those pop up on the screen so you have a little bit of an idea of what we're talking about there. And I want to start with by just creating a very simple shape, and I'm going to grab a piece in my assembly. I'm going to grab that circle right there and just start to extrude that. And we can give this any depth that we want, whatever size we may want that to be. But I'm going to also offset this in another direction. What this allows me to do is actually change its diameter at the same time as well. So, we'll just give this some basic size. I know that fits within the constraints of the other components in my assembly there. And that looks pretty good. But now I may want to only look at this part. I don't want to look at the rest of the assembly any longer. And I'll go in and start to use some of those synchronous commands that we talked about a few minutes ago. With synchronous, I can start to grab on faces and literally start to pull and push on these, even push them completely back off the screen until I create the geometry that I want. So we're going to remove all of that. Here I may grab this bottom section and I'm just going to push it back a specific distance. I don't want to push it all the way off all the way off the part. And then I'll grab multiple faces simultaneously as well and do that same type of an edit. So very quickly we've got the basic shape for how we want that plastic part to look. Now I'll go in and put some other geometry changes on here. As an example, I want to blend some corners. So I'm just going to select everything at once and go ahead and blend all those corners off at one time. I may as well want to go in and just remove the material out of the back of the design or hollow this part out. And notice how I can change the wall thicknesses by just dragging these around on the screen to whatever thickness I may want. I may know that I want about 1 millimeter in wall thickness. And then we'll go back to some more of those synchronous commands I talked about, where we can easily just go out and grab things after the fact, after I've modeled them, and make these design changes. And whether it was done here inside of NX, or if it was being accomplished on a third-party product, I could do this as well. I could bring this in from another CAD system and make these kind of changes. So what I want to do in this particular case is just take that vertical wall there and I want to rotate it or give it an angle. And the reason I would want to do something like that is because you need to put draft on a part like this in order to get it out of a mold. And this is very common where you may receive files if you're a mold development house, you receive files from a customer and they didn't put the draft angles on here, but you need to make the modifications. This is how NX can go in and very quickly accomplish that for you. Now I'm going to do that exact same command again so you have a little bit of an idea of where I'm going with this time. I'm going to grab all those faces. I'm just going to place this. This is just a little control component we use out here to orient things so we can give this a proper direction. And I'm just going to tell it, again, maybe I just want to put, and we're over exaggerating it here just a little bit with 10 degrees of draft angle on these faces, but it's so you can easily see how we've put those angles on there. Now if we flip the model over on the inside, we may want to put some strengthening ribs, give this a little more strength on the inside. So I'm going to go out and just create a very quick sketch. I'll just tell it where I want to draw something out here on the screen. And as we go in and look at this geometry, I may say, well, I'm going to draw a circle, and we'll just center it in the model here and give this some size that we may want it to be. And what's nice is NX understands that you may want to go ahead and just create that as some geometry. So I'll do so. And I'm going to use that same tool you saw a few minutes ago, but I'm going to actually do a symmetric offset so I can actually create wall thicknesses on this geometry as I project it out of the part, and very easily do that. And it creates this into my design, and now I've got that incorporated. But you'll notice that the height of that was a little bit too high. That's okay. We'll just do a very powerful tool, works in a lot more complex situations than this, but I just did a replace face. And if I flip the model over, you'll notice that as I built that geometry, it actually extruded out of those walls because of that angle we had placed out there. Well, that's not a problem. We can just go in and remove that geometry. And this again is using our delete tools that are incorporated into the synchronous capabilities out there within our product. So if you need to remove geometry, and this is very common when you're doing analysis, you need to remove some complexity in a model when you're going to go in and do a CAE analysis on a part like this. So the part looks pretty good from that standpoint. Maybe we also want to do a couple of other things here from a geometry standpoint, and we're going to add something else, and we'll put a dart into this geometry. And what a dart allows us to do is literally create a strengthening rib, and I'll just give this, whatever value I'd like this to come in and look like, and we'll do something like that, and go ahead and place it. And you notice the strengthening rib placed down inside. And now, back to synchronous again, we'll talk about doing copy and pasting of faces. Now I'm going to grab a face out here. The software is intelligent enough to understand, well, if I pick rib faces, it's going to grab all of those in one shot for me. And now I'll simply tell the system that I want to be able to go out and copy that over to a new location. So we'll just rotate that over to the other side. Now it just did a copy command. Now we're just going to paste those faces right into our design by grabbing that geometry, and now we've got that included as well. So you can see how very quickly we're able to create this geometry with some of these synchronous tools. Now one other thing we may want to do, we may want to place a hole out here in this particular part, and we're just going to grab it out there on a face and just give that a position where we want that to be. And then what size do we want that hole, or what type of hole? Would it be counterbored, countersunk, tapered? In this case, it's just going to be a through hole. So we show a display on here of what looks like a drill tip, basically drilling through the geometry. And we're just going to remove that. And let's go back and talk about using some of the synchronous tools to just drag a face now from the bottom there and give that a little more load bearing, a little more bearing area there for where that screw is going to come through for the rotation of this particular part. Now one other thing that we need is we need to create a cutout or a slotted shape out here on this front face to allow this to actually bend a little bit, allow the plastic to move. Now I'm going to do that by using one of our standard library components. So when you look at our standard libraries, we have things like bolts, nuts, washers. There's an example of one you see over here on the list. But you can also create your own custom libraries. You can create your own custom shapes that you may want in a design. And that's what I've done here. I've got this slot that I've modeled before. So I've put that into a library so I can use that at any time. And I'm simply going to go out and place that onto my existing part model. You can see I've positioned that out there within my design. And I'll tell it to subtract that from the body and go ahead and do that. But it actually can be kind of the reverse of what I wanted there. But that's okay. It's just how I selected things. We can just go back in and look at that and flip it the other direction. So anything you model, if you want to change it, you can certainly do that very quickly and easily. If we look at those synchronous tools again, maybe we've decided, well, that's the original slot from a library. But what if we wanted to be able to take this and actually change it so that the slot's not quite as long as what it was originally designed? I can use the synchronous tool to go in and change that very easily. And the last thing we'll talk here is about doing some of the more advanced surfacing or organic change type of capabilities. The tool I'm about to use allows me to put a mesh out on my design. Then I can take this mesh and literally just by grabbing some of these control arms out here, start to stretch on this model, start to modify it organically. So from an industrial design standpoint, make some design changes to it. If I flip this over, you'll notice that the material thickness is too thick here. We really want this to thin wall or match that outer curve. Well, Synchronous already sees that. Notice over here on the left-hand side, it sees an offset as one of the options. If I hit offset, notice now how it makes that material thickness consistent throughout the back side of the design. So understanding your design intent, very intelligent modeling capabilities. So with that, let's go back and talk about a few other things, and we'll wrap up by saying that, you saw me do some very quick assembly tools, ensuring fit, function, rotation. I did some very quick modeling capabilities with our synchronous technology. We edited the part beyond its original design intent. We made changes that maybe we didn't know about initially we might make. And it's very robust modeling with a parasolid kernel. That's the math engine that's underneath NX, as well as other products from Siemens. We write that math engine, and then we sell it even to third-party companies, like SolidWorks, as an example, uses that to build their entire CAD system on. And it's a fast and flexible modeling capability for you here within the NX environment. So let's look at something that industry has termed the innovation curve. And what this curve represents is the cycle or the life cycle of product development, from the very beginning on the far left down to the launch. And of course, what you're doing is losing money initially because you're spending money to get this component designed and out to the market. You get to a break-even point when you're selling that product, and then you get to a peak at maturity for selling all the way on out to retirement. So the issue is, how do you minimize the loss of revenue and maximize and make that a larger area for the profitability areas when you're selling your product? So basically, how do you make it so that the curve looks a little more like what's highlighted on the screen? So, speed to market. The Alloy company, that's the company that designs the thermal camera you've been seeing in the demonstration so far. They saw a 50 to 60% increase in what they were able to accomplish through their engineering efforts by implementing NX. By reducing cost, Samsung Electronics built 30% fewer prototypes and 50% fewer errors in their development, and were able to actually limit their development times by as much as 30% so they could get their products to market sooner. Renishaw, they were able to streamline their entire process by implementing NX with our CAM solutions as well, and saw processes go from weeks to days. And Dyson, highly recognized out there in the industry today, were able to improve their overall development, being able to look at more innovative designs and keeping the premium pricing that they demand out there today. So NX helps customers increase the number of new products introduced, reduce development time by as much as 30%, shorten design analysis iterations, and reduce NC programming and machining and tool design time. So an incredibly powerful tool to make more profitability for your company. So the next area we'll talk about is NX documentation. I'll be showing how we create a quick drawing sheet, maybe that plastic part we just created, as well as drafting views of assemblies with parts list and balloons, because assemblies require something a little bit different. And PMI, product manufacturing information, for 3D dimensioning on models, as you can see there in the bottom right corner image. So let's go out and take a look at that. As we go back into NX, here's the part that we just modeled, we just completed. And what I'll do next is just tell the system that I'd like to create a detailed drawing for this particular component. As I go out and start to create this, the system will automatically fill in the title block, do different things like that for me. But what I'm going to do is override a couple of things here on what I'd like to see. And I'm going to turn on a top, front, and right, maybe an ISO view as well. That looks pretty good. And we'll go ahead and accept that. Now I could have on the way in, but also I may want to go out and decide that, I'd like one of these views to actually come in a shaded display instead of just wireframe, and we can do that. So now we're ready to create some details on a part like this. And one of the things you may want to go out and do is generate section views. So we're just going to zoom in. We're going to take a look at this particular view right here, and literally just create a cutting plane down through the center of that. So we've got section AA generated. Now we can generate a section view from that and place that wherever we want on the drawing sheet, and we've got that created. We may also want to place a detail balloon and blow an area up larger on the screen so we can see a little bit more detail of what's going on in that particular area. And now we want to start placing some dimensions on these. So we just want to come out and, you'll notice that with the dimensioning command, regardless of whether I've selected a line, an arc, or a couple of lines at an angle to one another, it places all three dimensioning styles all in one command. So it doesn't require that you go out and create a lot of different dimensioning setups or have to click a lot of different commands to get into those. So that just very quickly gives you an idea of going out and creating a detail sheet from the NX modeling environment. Now as I come back to the model itself, I'm going to go back and say, well, I want to see the entire camera again. So we'll turn the entire camera display back on. We can see that part out there within our design. And we may want to go in then and actually make this do a detailed drawing sheet for this. So let's just go out. Once again, look at drafting for an assembly. And what I've done is I've created a detailed drawing with an exploded view here, placed very quickly on the drawing sheet. But in an exploded view or in an assembly, you may want to see things a little bit more different. So you may want to do things like placing a parts list. Notice just by the click of a button we can do that. Or placing balloons on all of this, and we certainly can do that, and it's going to go out and place all the balloons. And if we zoom in on a specific area, where do we want these balloons to be located? Just by dragging these around on the screen, that can very quickly and easily be edited. We can also align these balloons, by selecting multiple ones and lining those up. But I just want to give you a quick idea of what you would do to get in and accomplish something like that. And then finally, we're going to go look at one part here. And you'll notice that when I start working on that part, even with the rest of the assembly displayed, you see a lot of dimensions out here on the screen. And I'm going to turn off the rest of the assembly. So we just look at this part. So this is PMI data, or product manufacturing information. This has become even more critical to every company in the world, as they want to be able to put these dimensions here and then view this information on the shop floor, as an example. Many companies are going really paperless. Now, they're not going drawingless, but they're going paperless. So that this is a very powerful tool to be able to go in and do these types of things. So if I wanted to place some other dimensions on this, I certainly could do so. So I've already placed some in advance for you, just to give you an idea of the capabilities out there. But I also may want to go in, we're going to place a dimension here. Well, you notice the orientation of these maybe aren't quite what I want. Notice how you can just drag these around to any position that you need here, and then even move multiple dimensions simultaneously if you want. So very simple tools to accomplish that. I may also want to put feature control frame information out here and datum symbols and things of that sort. So I'm just going to go out and place a datum B out here on this, and then as well I may want to do a feature control frame, and you have all the different types of feature control frame information you may want here, from flatness to perpendicularity, angularity, all those things. We're using perpendicularity in this point. You can key in whatever values you want. You want maximum material conditions, what datum are we interested in here? We'll make this B, of course, to match up to that. And all we have to do is just tag on a face, drag to a location, and we've got those placed out here as well. So you can see how easily we can accomplish these types of things within the 3D windows with PMI, or product manufacturing information. So with that, we're going to jump back to the PowerPoint now for just a minute. And what we saw there was rapid documentation creation, automatic view creation, obviously linked intelligent dimensions. If we change the model, those views are going to update. Clear and accurate to standard capabilities. So whether it's ISO, ANSI, DIN, we have all the world standards built into the software. You click on that, and that's the standard that we'll use to place everything. And then, of course, a product-proven 2D drafting capability out there within NX. So the last area we'll discuss is, we started this out with talking about the full integration from art to part. So that's really the true power of what NX represents. So from concept design through detailing, maybe analysis, drafting and documentation, tooling design, CAM, all those tools are built into our suite of products. And if we make a design change at the very beginning of the part, it will ripple through all of our other applications. So with our multidiscipline simulation capabilities, you may want to do things like vibration, durability, flow analysis. All of these can be done with our CAE tools. And within CAM, for computer-aided manufacturing, it's one model that drives everything downstream, as we discussed, to be able to very quickly generate toolpaths on those components for manufacturing processes out on the shop floor. All in one system, one vendor. When we look at this, here's kind of what to look forward to in the next section of the next demo. I'll do a little CAE analysis, give you an idea of analyzing that plastic part we just looked at. We'll generate a report as well. And then we'll go into CAM and look at toolpaths, ones that are already existing, but we're going to go back and make a design change to that part we started with and see how that ripples down through the applications. So let's go out and take a look at that. So here's where we were just moments ago, but now I'm going to go out and look at this plastic part. Now this one has a little more detail even than what I had modeled for you originally. But what I want to do in this particular case is go out and look at an analysis for this. So in order to do that, we have tools that allow you to very quickly apply a mesh to this part, tell it what loads are going to apply to it, where it's going to be constrained or held down, and then go out and show us the results. So as an example, one of the results for this particular part would be the displacement. And this shows the mesh. You'll notice the mesh density is much smaller in the areas of interest we have here. Up here, we're probably not too worried about it breaking, so that's why the mesh density is much wider. But down here, what we're concerned about, remember when we modeled these shapes out here, is that it needs to bounce over, or actually as you rotate this part, it bumps over this other piece of geometry in the model. And when you do so, what's going to happen? Well, it's not going to cave in as deep as it shows there. We over-exaggerate that intentionally so you can see what's taking place. But we can also play this as an animation, so you have an idea of what happens as that part is rotated out there, and just gives you a much better idea of what's going on. We can also look at strain on the part. There's a lot of different operations you can look at the display of how this part may look. And then you can also go out and tell the system that you'd like to have reports for this particular information as well. And the way we accomplish that is just by telling the system we want to generate a report, and you'll see that pop up here in the list and down on the bottom left-hand side of the screen. And we can create some images. So let's just zoom the screen up here a little bit closer, and we'll just say take a snapshot of that, and it just did that for us. And now we'll say that we want to generate or export this report. What's nice is you can go in and analyze the part, get the results that you see here on the screen, and then pass this information off to a true expert analyst, and he can evaluate the entire process, what was done through this analysis, what the results are, and determine whether or not you need to look more deeply into this component to see if there's some problems. So you'll notice here it was just created by me. I can go in and look at all the different bits of information relative to this. It's even hyperlinked or hot linked over here on the left-hand side of the screen, so I can see what the material was we were using, what mesh densities we had created, what the loads were that were applied to this particular component, and maybe what the results are, of course, the most important aspect of this, and even the image that we saved out there with it. So now you can take this, it's just an HTML document, and you can pass this off to anyone so that they can take a look at how you analyzed a component out there within your design. All right, and finally the last area we'll look at is CAM, and how when a part model changes, how everything ripples through based on that design change out there. So what we're going to do is look at this part. Now what you'll notice is it kind of looks like that plastic part we were working on. This is actually taking the plastic part and adding some material to the back side for a portion of the mold. So this is one half of the mold. And what we want to do is we're going to go in and look at just this part for just a minute. And as we do so, you'll notice there's the plastic part sitting in there. And if we toggle some things on and off just based on our display here, and I'm just going to come into the modeling environment so you can see this a little more easily. If I turn the body off of the part, you'll notice there's the mold itself. Right? Now we're going to turn that back on so you can see the plastic part. And now we're going to hide the mold and just look inside the model here and maybe make a design change. We've got a blend that's up inside that corner, and that's fairly small. Maybe we want to change that to a newer size. Now I'll upgrade that. You notice how that's changed to a new value, right? And now if we bring back in the mold base itself and turn back off the body, you can see that it's already updated for those blends are now the new size. So let's go back and look at this on the manufacturing side so you have a better idea of what just happened. So what we'll do in this particular case then is just come back to manufacturing, and then we can display exactly what's taken place here. If we look at the original tool path that was already generated for these components, you notice it's fairly flat, this light blue color, and you'll see that it has just a very small roundover out here on the end. But the new blend, which is now updated in a new color, gives you an idea of what's taken place there. All we have to do is hit generate, and the system goes out and rebuilds the new toolpath for us automatically, as you can see. We can even simulate this if we'd like to. So if we want to go in and actually we can even look at the entire component here and just verify the toolpath. And we can see all the toolpaths in a 3D wireframe type of environment. But we can also go out and just display or play this through an animation and actually see how the part is being cut from that original piece of material to get to our final design. So you can see here in just a matter of minutes, we're able to go out and make that design change to the original component and how that's going to update on the tooling side automatically for us. So with our integrated CAE and manufacturing capabilities with the CAD platform in the first place, we're able to reduce physical prototypes. We have best-in-class simulation. You can use Nastran, ANSYS, Abacus, LS Dyna, whatever solution provider you want. Industry-leading manufacturing and application-based master model functionality for an integrated design, analysis, and manufacturing capability. So with NX, the real advantage is that we have the most integrated, flexible, and efficient solution for product development, where no other tool offers the synchronous technology for flexible open design environment, an integrated multidiscipline simulation tool that's tightly integrated with the CAD models, and such a full range of advanced manufacturing applications. And it can all be integrated with Teamcenter, our world-leading PLM platform. So with that, we'll open things up to questions. And if there are no further questions, I'd like to thank you very much for your time today.